Today I'm going to teach you guys about buoyant force. What exactly is buoyancy? Buoyant force is the upward force acting on an object in a fluid that is equal to the weight of the fluid displaced by the object. This force always acts vertically upward. Now I will illustrate where this force comes from. When an object is placed in water, pressure is exerted on this object. It is assumed to be a static system, so the forces of water will act on all sides of the object equally. Therefore, the sum of our forces equals 0. Pressure is a function of depth, so when an object is in the water at any given depth, there is a pressure differential, with higher pressure exerting on the bottom of the object versus the top. This difference in pressure is known as the buoyant force. Our equation therefore becomes the force of buoyancy equal to the weight of our object. What does this even mean? Whether or not something floats is determined by the weight of an object compared to water with the same volume. If an object weighs more than water, the buoyant force acting upward is less than the weight acting downward, and the cube will accelerate downward. If an object weighs less than water, the buoyant force acting upward is more than the weight acting downward, and the cube will accelerate upward. Lastly, if the object weighs the same as water, equilibrium is reached and the object will float. What are other conditions that affect the buoyant force? Buoyant force depends on the density of a liquid. Remember that density equals mass divided by volume. The density of water is 1,000 kilograms per meter cubed, so if an object's density is also 1,000 kilograms per meter cubed, it will float. Applications to the human body. Muscle and bone have densities greater than water, whereas fat has densities less than water. It makes sense then that people with higher body fat percentages can float more easily. Once afloat, a person's position in water will help determine how well they float. If a person is floating with their legs straight out horizontally, they'll have a more difficult time floating because their center of volume, where the buoyant force acts, is not in line with the center of gravity, thus creating a torque. Bending their legs under the water slightly would allow for a more stable floating position by aligning the center of gravity and center of volume. Thanks for listening, and I hope this video helped you understand